All right, time for another draftphysics.com, debatephysics.com, also video presentation. So, thinking about the pendulum experiment, the free momentum experiment, I was thinking of a way of doing it that should be able to provide a better proof of what's actually happening, a more secure, definite, useful piece of evidence. So the basic experiment is you're taking a one mass and swinging it into a three mass, and you're supposed to get 150, 50%, 150% of the momentum in this object, and 50% in this one, so you put 100 in and you get a total of 200 out, in the sense of 200 movement. So you have a certain amount of movement in the universe, then you have twice as much movement in the universe in terms of atoms and protons and electrons moving. All right, so the way to do the experiment to evade all these difficulties of measuring velocities and whatnot, as I have suggested previously, what he should do is Dispar, who has timing gates, is first just swing the object. Okay, so take the one mass object and just put your little thing on it, some little flag. Whatever, let it swing through your timing gate, okay, and measure its peak velocity. So you find a position for the timing gate, okay, that's at the bottom, likely at the bottom of the slope. That's the highest velocity that you can get, and then you just leave that alone. All right, and then you can now just take different height objects, okay, and you allow the object to just swing it off of it. So you just move this away, the ball falls off, and you should get a pretty consistent fall. Okay, so the idea will be you do it from a certain height. You do it a few times, 5 or 6. You find out whether you get the same exact speed. All right, then you're measuring a very precise speed. And then you just do it with different heights, and you find a height that's exactly twice that speed. Okay, and it's going to be somewhere in this location. It will be, disproportionately. It will not be at half the distance away because of the arc and the fact that the energy gets a lot more intense the more it's falling down rather than going sideways. So it should be somewhere around here is where you get 1/2 that velocity. So you have a one velocity, I don't know what to call it, pedestal. One velocity pedestal and a 1/2 velocity pedestal. Now you know exactly what kind of speed you're getting. So now you can do the experiment with the 3 mass in the experiment. You do the experiment without bothering checking any of these velocities, because you don't need to know this anymore. You just need to know the location of the pedestal, and you just move the pedestal just a tiny bit back so the ball won't hit it, right? And you see if this comes back to this half speed. So you drop it from the full height, the full velocity. All right, so let's say this velocity was 20, okay? Then you find the 10 velocity position. You move it just a hair back from there, so you have a good mark. Then you do the experiment with the 3 mass connected, and you see if it comes back to the half velocity mark. And that'll tell you whether it has half the velocity. Now, it'd be even better if you have a pedestal for the quarter velocity also, okay? So the one, because that's the one I'm going to say is going to be the truth. The quarter velocity is going to be somewhere around there. So if it only comes back to the quarter velocity, then we know it only has 1/4 of the velocity. So we don't even need to worry about this one, measuring it. We just need to know this one. If this one comes back and goes half the speed, we know both of them are going the same velocity. This leaves with one, with the same velocity that this one does in the experiment. And the real argument is whether they're going 1/4 or going 1/2 the initial velocity. So this way you sort of have a guarantee. So you do the timing gate to make sure what the velocity is at that peak coming from this height, and you figure out what these other heights create as velocities, and then you have a good measure. And even with a pretty shitty camera, you should be able to tell the difference between this mark and this mark, and which one it reaches on the rebound. So that should work. Frankly, since you've got the materials and the stuff, you might as well try it. It'd also be interesting to find out how much energy you are losing. So it would be nice if you just did the experiment and let it play out and see how many times it keeps oscillating. And you can figure out how much velocity per oscillation it loses. All right, so that's enough of that. Now the Ian Gosling moron has made another video, and I've tried to make this so simple. So the argument is that gravity is a time-dependent force. Okay, and so my argument is that it's just like photons. So if you're going to measure how much pressure is placed on a surface by gravity, you're measuring it just like as if it was rain or as if it was photons. And you're just saying, are the photons hitting? Now, if the thing is not moving, that is, it can't move, then the idea is that the photons are going right into the ground. And the idea is the rain goes right into the ground. So it can't collect rain or it can't collect photons if it's connected to the ground. So that's the only catch here. And we're just really saying that the fact is it's really just about how long it's exposed to the gravity and allowed to move in the gravity will decide how much energy it collects. So it's a time-dependent force that, yes, twice the height, okay, it will give you only 4 times the height, woof, will only give you twice the time it takes to fall. So it'll go 4 units of distance in only 2 units of time. And if it was just falling 1 unit of distance, that would be 1 unit of time. So you can sort of get the idea that this should be 4 seconds if it wasn't a time-dependent force. But it is a time-dependent force. You only get 2 units of gravity. That's why you're only going 19.6 instead of 40. All right. So we'll play his video. I haven't played it, but I'm sure it's going to be moronic in the sense that you could just watch the video and you say, well, if it was rain, okay, how much rain is in the bucket? And it's really just about the fact that it's going to collect it if you're moving it in a circle. Okay, that's the same thing as moving in a circle in the sun. You're going to get a suntan. So that doesn't make any sense. It won't work. So it's just so bad. He just doesn't pay any attention, and he just keeps contriving these nonsense experiments. So what he hasn't done is taken my suggestion of just putting an amp meter on these motors that he's using and see how much electricity they use to spin twice as fast, and see, or 3 times as fast, or 4 times as fast, and see if it's 16 times as much energy to spin it 4 times as fast. Seems a pretty simple experiment. I don't know why he won't do that one. All right, so we have to find that page, and all right, we'll see. Test of gravity in a time-dependent force. Test of gravity is a time-dependent force. Okay, puts that in quotes. And this will be an idiotic experiment that won't be testing for what he claims he's testing for.
Hello, everybody.
I mean, it's the simple argument that, you slide across ice, and what are you doing when you go fast across thin ice? You're distributing less weight on the ice. It's just a fact. That's why you don't fall through the ice, is because you distributed less weight. And your weight is completely being created by how much gravity you're exposed to. And the fact is that you're exposed to less because you've moved across the surface quickly. Just a fact. You weigh less.
I've cleared my bench off. About leaving time. We're going to do a test about Gary's theory. this is
He just keeps doing this kind of horse shit. It's not a test of my theory. It's not going to be able to glean the information you claim it is because you're a moron and you can't pay any attention.
There's a path across the surface. We're looking down on the surface of the Earth, say.
So he keeps, you've already done this bullshit. Looking down at the surface of the Earth, how does this have anything to do with the thin ice argument or the argument that as you go across a surface quickly, the scale, if you put a scale in your path, that the quicker you go across this scale, okay, now and obviously it has to be a certain quickness. I mean, if you're walking really slow and then you decide to walk a little bit, tiny bit faster, right? You're not going to weigh any less. You have to go faster than the force of gravity. That is, faster than 22 miles an hour. If you're not going faster than 22 miles an hour, you will weigh the same. So that's the catch. You know, is that you have to go faster than you acquire your weight from gravity.
We're in plan view. And I've divided.
It might be faster than 1 mile an hour, actually, frankly, because when you're standing still, it's 1 mile an hour of momentum. Your velocity is 1 mile an hour.
The length of the path into sections, the distance of which is not really important.
So again, if this was a photo detector, so there's a little photo detector that's going to move across this distance. And the argument is clearly the faster it moves across the distance, the less photons it's going to read. Okay, no doubt about it. If it was a bucket and it was collecting rain, the faster it goes across this distance, the less rain it's going to collect. Just a fact.
Now Gary says that the faster we traverse one section, the less force is pushing down on that surface.
Yes, absolute fact.
So we'd lose less.
The less photons you will see, the faster I move the diode across that. I have a light source and I have a diode. The faster I move the diode across the light source, the fewer photons I collect. I have a paint sprayer and I'm going to move something quickly through the paint. It only collects a few specks of paint. All right, I move it slowly, it collects a lot of paint. He's going to defeat that argument with this nonsense.
Friction, or we would be less likely to crack this ice. Such. And then
So yes, I've made this argument hundreds of times. So here you are poorly reciting what I've stated hundreds of times.
The faster we go across each section, the less we would weigh on each section.
Yes.
So you could have a scale under each section and they would all register less the faster we go across.
Right, and you're saying that doesn't happen, which is pretty much insane.
Okay. Now it would make no difference if that linear path was turned into a curvilinear path.
How would it make no difference? You're still going to put an individual scale under each path unit, right? You're not going to measure the whole road, are you?
And each unit of distance is now circumferentially spaced. Each unit.
So I don't know why he needs to do this, right? I mean, what's the point of it? It's going to clearly depend. So if, again, I took a photo detector and I moved it around this circle and I move it really slowly, it's going to collect a whole bunch of photons. I move it really fast, it's going to collect very few photons. Absolute fact, and it's the same fact for gravity.
Unit of distance would have less pressure exerted on it the faster we move across it.
So how is he going to contrive some nonsense experiment to do this circular path thing? How he's taking point A and point B and making them into a circle, and somehow that's going to solve the problem some way. Again, how could it possibly change anything? It doesn't make any difference whether I'm in the paint sprayer and I go in a circle, or I'm in the paint sprayer and I go in a straight line. It's the same distance. Can't make any difference. As long as I'm going from a place where there's no paint to a place that there's no paint.
Fast forward. Now we've got such a circular track around.
So it's one scale. So this is, so again, he talks about per foot or per inch, and then he decides to measure it as one scale measuring the entire road. Yes, you won't change the total unless you put it on the scale and take it off really quick. So now we're just talking about how quickly it's on the scale, how much time it spends on the scale is all that's going to matter. So how are you going to change how much time it spends on the scale, retard? I mean idiot. I mean fucknut.
And the circumference of this scale.
Too big an
idiot.
You
don't need the individual scales.
So right, if you took anything, if I took a ball bearing and we made a track and we could shoot the ball bearing in here and it would curve right around this track and then come out the other side, the same rules would apply. The faster I move the ball bearing, the less weight the scale is going to read. But if you leave the ball bearing on the scale, then it's game over. There's no point in doing the experiment anymore because there's no in and out of the exposure to the gravity. You're just saying, I'm perpetually exposed to the gravity. I'm perpetually on the surface. Of course you can't make any difference if you never take the object off the scale. I'm calling it a time-dependent force. You don't understand that you can't leave it on the scale and then say, oh, that's time dependency. No, it isn't.
This is going to be our weight.
So how does it get off this? How does it get off the scale? How does the weight get off the scale? After turning one time, how do you get it off the scale? Yeah, that's right. You don't take it off the scale. What a fucking idiot. You're just saying, I can't believe people are this stupid. I mean, they're just trying so hard to fake an experiment, to make some kind of argument, and it's just so bad. I mean, this is so bad.
Traversing each unit distance.
Why would somebody contrive this? Again, all he had to do was take the scale he has, take it as a section, and just take plywood on this side and plywood on this side, and then just roll objects across it and see how much the scale reads. And you'll see that the faster the thing goes across the scale, the less weight the scale reads. That's all he had to do. What's this horse shit?
In an increasingly small unit of time. The faster we traverse a unit distance, the less...
Right, again, and how are you going to take the weight off the scale, you fucking idiot? You know, how's it going to rotate once and then get off the scale? How is it going to do that? Oh, that's right, it's not going to do that. I mean, just too stupid.
Force we exert upon that unit of distance. According to draft science. Well, let's test it.
Okay, this ain't going to be anything like a rational test.
I'm going to use this drill.
For what purpose? What fucking purpose? You're spinning a weight on top of the scale and you never take the weight off the scale. Of course it's going to weigh its weight. You can't change its weight by spinning it in a circle when it's constantly in the gravity. If it was a photodiode and I spun the diode, it's not going to change how many fucking photons it sees. If I have a bucket and I spin the bucket, it's not going to stop the rain from falling into the bucket, you fucking idiot. Oh, shit.
To turn the wheels. In the position of the...
So again, just think of this as a spinning bucket. And he's proving now with a spinning bucket that somehow the rain doesn't fall into the bucket per second. A certain amount of rain per second falls into the bucket and it collects water based on how long it's sitting there. And he has it sitting on the surface, which means the bucket constantly leaks into the scale. The pressure it's creating goes right into the spring, right into the ground. I mean, oh, he's just so fucking stupid.
The drill makes no difference to the weight. It's not pressing on the scale.
I mean, it's really just so stupid, right? I mean, there's no, like I said, the logic is again, he's just saying if I spin a photodiode, somehow the photodiode doesn't collect the same number of photons. No, of course it does. The whole point is you have to move it through a field of rain or in a field of light. You can't just go back and forth and say, look, it's constantly in the force. No, it has to go from a place where it is in the force to a place where it's not in the force, or it has to go across your measuring device, your scale. So the simple experiment is cut a round hole in a piece of plywood for your scale to fit in, and then just roll something across the scale, and you'll see that if you roll it slowly, the scale will weigh more, and if you roll it quickly, the scale will weigh a lot less. Fact.
That kind of idea.
Pointless. It's constantly in the gravity, constantly putting pressure on the ground. How are you checking time dependence here? There's no timing. There's nothing being timed. You're constantly putting the same weight, exposing it to the same gravity, and weighing it with the same scale every second. You could do it for 10 minutes and it's going to keep reading the same exact value because you aren't changing anything. Oh, you're just so stupid.
And we'll do it at different speeds. There is some jerkiness, of course. I can't do much about that. That's what the rubber tires are for on the wheel.
Right. So you could just imagine a spinning bucket, and his argument, his expectation is that somehow by my theory, so if I put a bucket in the rain, okay, and we're not going to move it this way or that way, we're not going to move it through rain, from a covered shelter in the rain, uncovered shelter. Instead, we're just going to stick the bucket in the rain and then spin the bucket, and somehow less rain will get in the bucket. Clearly, that's not my theory. My theory is, no, you're going to collect just as much rain as if you just put the bucket in the rain. Just leave the wheels sitting there. You don't need to spin them. If they're constantly on the scale, they're going to constantly putting weight on the scale, you idiot. God, it's so stupid.
To absorb the vibration. But we can get a mean value, a rough value. I'll zoom in a bit so hopefully you can see better.
Too silly. I mean, just look at this. Look at what he's contriving. Look at the trouble he's going to contrive some wacky experiment. Has nothing to do with anything I've ever suggested. So this he's saying is the same thing as rolling this object across the scale. This experiment duplicates rolling across a scale. So he's actually says this is the same thing. He's saying he's doing an honest thing here, that rolling something across this surface is the same as spinning something on top of the surface. Oh, God damn. The desperation of these people. They just have to keep trying to, put... It's just like they're trying to, make kind of like, whatever, your snowshoes, and they put plastic on them so they can walk on water. Some kind of... Jesus could do it. Jesus had really big feet.
The mean value is about 2 pounds.
Exciting.
Now, if we traverse each unit distance faster.
So it's amazing. He's on the scale. What did you traverse? Did you traverse the scale faster? No. Did you traverse the ice faster? He's spinning on the ice, and he's saying, because so it's like there's thin ice. And he's saying that somewhere in my theory I said you could, if you spin on top of the ice and you never change your position, that somehow you won't fall through. Of course you're going to fall through. Of course you're going to be applying the full pressure of your weight. You're not moving across the thin ice. You're standing right on it. Spinning's not going to stop you from falling through. Oh, just so ridiculous.
according to Gary, there should be less pressure.
No, it's not according to Gary. That's just a fucking lie, you fucking idiot. Of course Gary wouldn't say there's less pressure because you're spinning on top of thin ice. Oh, god damn, what an idiot.
Exerted, because there's less time.
There's no less time. You're constantly on the surface. Where's the less time? You could go as fast as you want to, and you're constantly on the surface. You're never off the surface. You're always sitting right on the surface. Oh, just so stupid. I mean, I knew it was going to be stupid. You could just see. As soon as you saw a drill and a round thing, you're saying, oh, fuck. He's just going to do another stupid, fucking contrived pile of shit nonsense video. Oh, god damn.
I'm not seeing any difference. You?
So we know that, in gravity, if you go sideways, it doesn't change your falling this way. So you shoot a bullet and it falls the same time as a bullet you just dropped. So I could just drop a bullet, hits the ground the same time as the bullet I shot horizontally. Yeah, so we know that going sideways isn't going to change the gravity any. Moving around in a circle on top of the scale isn't going to change how much water the bucket collects. I mean, just too stupid.
The average is about 2.
Amazing waste of time. Ridiculous.
I think that's pretty clear myself, and I can't see any reasonable objections to it.
Oh, brother. Yeah, we just,
but of course
because your brain is a piece of shit. Your brain is garbage. I mean, if you can't figure out that, well, if I spun a bucket in a circle, it'll collect less water. Yeah, sure it will. Yeah, that'll prove him wrong. Because, well, wait, no, that's right, it won't collect less water. So that'll prove that nothing. That's right. That'll prove nothing. I'm an idiot.
I think my battery's died.
Good. I wish the rest of you would die.
That's a shame. I would have done some more.
Yeah, it was very exciting.
Anyway, what do you think about that, guys? Any reasonable objections?
Yeah, complete contrived nonsense. 18 comments, so we'll see if any other
I'm
idiot...
afraid my drill's expired, chaps. Can't do any more.
Oh,
but anyway, I hope you
so
enjoyed
tragic.
That. And let's see if anybody's got any reasonable complaints about it, shall we?
Okay, so let's see what the comments are, right? Because this is so ridiculous. Oh, god damn. Let's see. Have you gotten into superpositional states or triple branching paths of photons, or should I come back for that? I don't know what that is. These people can't stay on the subject for a second. Okay, so Piro. So Piro's not going to be smart enough to figure out that spinning a bucket won't change how much water you collect in it. Something occurred to me. According to Gary's theory, the weight and the time and energy... Yeah. Running 5 miles at top speed should take less energy for a person than walking 5 miles. Well, you're obviously in the gravity less time, are you not? Isn't that all that matters? Is how long you're in the gravity will decide how much work you're doing. So just standing up is work. You're fighting the gravity just standing up. And so the simple argument is the faster you get from point A to point B, the less gravity worked on you. So technically, the less work you were doing fighting gravity. Duh. All right. The faster you go, the less energy you would use. Yeah, exactly. That's how rockets work. So, Piro, are you really stupid enough to think that if the space shuttle lifted off at 60 miles an hour and just stayed at 60 miles an hour, didn't bother going real fast because it just makes a bunch of stuff shudder. It causes all kinds of trouble. So let's just take our time. That it wouldn't use 1,000,000 times more fuel. I mean, literally 1,000,000 times more fuel. That's how important it is that it gets up to thousands of miles an hour going through the atmosphere. It doesn't want to go that fast going through the atmosphere. It doesn't want to be going 3,000 miles an hour in the atmosphere. All right. But it does it anyway because it needs speed. It's just so stupid. You have to get up to your orbital speed as quickly as possible. And the slower you do it, the more fuel you're going to have to use. It's just an absolute fact. I can't believe this guy has any physics understanding at all. All right. So this Phoenix thing, whatever this weirdo is, icon modicon-y thing, woot, I'm going to need to see him do squats for 3 minutes straight and fast as he can. No stopping first. Does he even understand what calories are? So what does that even mean? What is that slop? So these people don't believe that the faster you lift a weight, the less work you do. And if you spent 3 hours lifting 100 pounds, you just lift it really, really, really slowly, that you wouldn't do 1,000 times more work. Okay. Yes, great. Fast we work, the less energy we use. Why did nobody realize? So again, I think NASA did realize. That's why it launches rockets at the fastest speed possible. I mean, it would be so much more efficient if they go through the atmosphere really slow. But they go through the atmosphere as fast as they can. They'll even risk blowing up the shuttle to do it. When there was a shuttle. All right. So Falwell says, even if you have added weight too. So this is some moron short he made. So let's go ahead and watch it, I guess. Let's see. Cameraman wins gold. So obviously the cameraman hasn't run 400 miles, right? These guys have probably run around the track a whole fucking bunch. So this is relevant somehow. Very exciting. So far, not very interesting. So far, profoundly uninteresting. Why would somebody even watch this fucking piece of shit clip? So you gotta say, why did Falwell actually watch this? Whatever this shit is. This goes on and on and on. I'm falling asleep. Yeah, so these guys probably just ran 10 fucking miles, right? And the cameraman just ran 150 yards. Yeah, fuck. These people are such creatures. They're so fucking, whatever you call those things in like Lord of the Rings, those little, whatever those things are, Morlocks or something. Just such little retarded monsters. All right, that's it. Proof. Someone let Gary know. So, he would probably take this as evidence and run with it. God, these are such brilliant counter arguments, aren't they? Aren't they really demonstrating how gravity's not a time-dependent force? Oh. Well, what a shock. It doesn't become lighter, not. So again, he's saying that spinning on thin ice it's my theory. I have said in videos that spinning in a circle on thin ice will prevent you from falling through thin ice. But somewhere I made that argument. No, that didn't happen, moron. All right, nice innovative setup, Ion. Ian. Okay, you do some cracking builds, mate. So he does some great evasions of the experiments that'll actually show something and instead contrives nonsense so he can rig it and try to fool people. And that's all he's doing, is just trying to fool people. All right, so Brozo says, I wish to register a complaint about this parrot I bought. Oh, it's another Monty Python joke. I mean, Jesus Christ, these guys are like one-hit wonders from 1942. Oh, God. All right, what's wrong with it? Okay, it's dead. Okay, that's funny. Ha ha ha. No, just going to whatever this is. The Freuds. Okay, some kind of joke. Haha, pet shop owner. Okay, never mind, right? Just no, nothing. And then Brozo says, excellent. So they think by proving that if an ice skater spins in one place on thin ice, that they'll fall through the ice, that proves what I said wrong. Hilarious. I mean, it's just so bad. I mean, these people are just so criminally, evilly perverse and just so dishonest, just so disgusting. So I probably should download this video and just to prove, that there's just no credibility to the physics, right? This is what they have to resort to. Something so dishonest, something so nothing like the experiment I've suggested at all. I mean, it's just so bad. This is the best they can do. Amazing garbage. All right, so enough of a video. That was just so bad, so bad. All right, God, I just hate it here on this planet of assholes. Just amazing how fucking shitty human beings are. No character, no integrity. They just can't do anything honest. They're just disgusting. Disgusting.